Okay, so we're live. Okay, so you are required to work, so we have a distribution applet here and two.
Just a second, because mine did not open yet.
Okay, yeah.
I don't know if my internet. Oh, okay, now it's open. True. Okay, the distribution applet. Let me download it to Excel. Okay. Okay. When calculating anything, please. Por que ela nunca fecha a porcaria da porta? When calculating anything, please remember to round to 3 decimal places, unless otherwise specified. Okay. What requirements? Let me get my notebook. Thank you. What requirements must be checked when conducting a hypothesis test comparing two means with independent samples? I did wrote this down.
Yeah, me too. Let me get my notes.
Independent samples.
What happened? Okay.
I think the second one.
What requirement will be checked for conducting hypothesis comparing two means with independent samples?
Probably the first.
Let me just with independent examples. Give me a minute. Okay, so
I am not 100% sure, but I think it's the first and the second.
So I have the steps. It says start the node, compute statistic determinant. Oh. What? I wrote this. I'm like trying to find where I wrote it for the.
Mommy, I want where to go start.
Hold on, Camila. I'm sorry.
No problem.
Sorry. Okay, I'm sorry. So normal distributed.
Okay, I know the fourth one is wrong because it says, my note says, samples are independent if knowing who was selected for group A tells you nothing about who will be selected for group B. So I know the fourth one is wrong. And I think the third one is wrong too because the mean doesn't have to be bigger than 0. Like, I don't remember anywhere saying that the mean has to be bigger than 0.
Yeah, I think that the first one, a simple random sample, was drawn from each population.
And I think the second too, because.
Oh, it says mark all that applies, so it may be both of them.
I know third and fourth are not for sure. And then I think first and second are. What do you think?
Okay. Yeah, I think first and second.
Okay.
Yeah.
The test statistic for a hypothesis test comparing two means with the independent sample is a good question.
Okay, hold on.
I think it's t-score, but I'm not 100% sure. This is so confusing for me.
Okay, so number 4 says the test is to hypothesis test compared 2 means with the is a T-score, no? The 2 with the in the, so I have my notes. 2 compared 2 means with independent is T distribution. Says name of the distribution from which the test statistics computed is a T distribution.
So the T-score?
The T-score, yeah. Yes. T-score.
Yeah, because also he offered the T-score Apple, so if it was a T-score, it would be the other one. Two samples are independent if knowing which subject will be group 1 determines no. Knowing which subject will be in group 1. That was the second one.
That one was yeah.
Yeah.
Okay, so the dentist office.
Okay, let's open the cell thingy.
Okay, so
let's do the difference first, then we can answer.
To the dentist. Then this.
I'm doing already the mean and standard deviation, okay?
Yeah, I'm copying the information to the Excel sheet. So.
Okay. Let me copy too. So how much did you get for the mean?
I'm still copying the information. Sorry. It's slow. In the second. Okay, so I have this asking for the degrees of freedom, right?
Yeah, the dentist one.
The DF, right? So 37.996.
Wait. Are you at the dentist office 1?
Yes.
Did you do the difference already?
I just plug the information on the wait. These are two independents, right? It's supposed to be independence variables, right?
Oh, wait. I misunderstood. So we don't do the difference for this one. We do a mean for one and a mean for the other one, right?
Yes. Yeah, I believe so.
Got it. Okay, my bad. Just a second. Let me do again. So for the first one, I got the mean 260.059.
Yes.
And the standard deviation, 1 second. I got 208.8755. Right?
The standard deviation for the second one?
280.8755.
Yeah, the standard for the first one, the standard deviation.
Per person. Now I'm gonna do the second one. Okay, the mean for the second one is 288.597. Is that what you got?
206.637.
For the second one?
Yes.
No, that's the standard deviation.
Oh, I'm sorry. Yes, yeah, you're right. The mean is 288.597.
Okay, so now we need to open the table 2 times, right? Because we need one information for each, right? That one sample t-test for means table, you know? The one that you sent by email?
Yes. The Excel is called the quantitative inference procedures.
Yeah, we need to open twice, right? One for each data, right?
No, like let me show you my screen so you can see
Okay.
which screen I have. Okay. Oh no, it's doing half. Did you see my screen? No.
Okay, I have a different one.
Yeah,
I
so
have
I
the
put
other one.
variable 1 here, but it has to like and variable 2, but you know how it has 3 tabs in the bottom? It has to be the 2 sample test because they're independent. The pair is when they are, you know, like dependent of each other. So it has to be the 3rd tab. And it shows
But
you
mine, wait, it's opening. I think mine has space for just one.
yeah, in the bottom there is, you know, 1 simple test and then pair.
Oh, got it.
They're in the bottom tabs.
Okay, just a sec. Let me put the information. I'm sorry. I'm kind of.
That's okay.
I'm like super tired.
Like
So I'm not thinking well.
Slowly and good, then, you know, hurry up and don't.
Okay, 260. 0059. Ah, 28208.876. Shh. Sorry, Julia.
It's okay.
My computer is not helping. The N is 20, right? The sample size.
N is just the samples, yeah.
Okay. So the type of test is not equal, right?
I'm sorry, what?
So the data below is type of test not equal to, and assume equal variances. No, is that the right answer? I mean,
What questions are, which question are you?
in the table, quantitative interference procedures. It's a confidence.
Yeah, the one. Quantity inference procedures. Yes.
So type of test not equal to.
The kind of test is 2 sample test.
No, I know.
I'm sorry.
See the table, 2 sample test for means, right? We just fill out the blank spaces. Then below there's another table saying confidence level 0.95.
So we don't use that one until they tell us.
Okay, because
Yeah.
we didn't read the information yet. Sounds good.
So right now, like for number 6, we have the information, and until they change us the information, then we can input more information.
The degrees of freedom is 19, right?
I think it's DF, right? Degrees of freedom. You know what it says,
Okay, so
equal
it's
values not assumed.
4.473.
And I got 37.996. What it says, 2 sample t-tests. It says t-value, DF, p-value, and confidence interval.
Uh-huh.
Let me share my screen again.
It's the DF, right?
Yes, I got 37.996.
I got 4.473. Show me your screen, please.
Sure. So I got DF, just 37.996.
Wait, you didn't fill the information in the first table. Why?
This one?
Yeah,
Because
I put the information in there.
okay. Okay, so 2A. I don't remember filling out this information when the teacher was doing it. So
Because I think we filled this information and then the others down fill automatically.
we didn't change anything.
I think because you filled first the other one. Let me show you mine. Can you see? Because like when I filled here, then here it will be a different number.
So
See?
this shouldn't change. That where you're highlighting shouldn't change, because that's the information that I took from this to put it here.
I don't know, because I thought she was supposed to.
No, like the variables. No. I see what you see. Can you put your screen again? You see where you have variable 1 and variable 2?
Yes.
That's you're supposed to paste the information from the dentist office, the Idaho Falls dentist office, and one variable, the variable 1, and the Rexford dentist office and variable 2. And that's how it's gonna give you the information automatically.
You mean all the numbers?
Yes, copy and paste.
But
So
there's
I'm
no
gonna show you
space.
my screen. Let me show you my screen now. So like, you paste the information here, the first, and then the second one here, and then it counts automatically, counts the information.
But it says mean.
And then what? I'm sorry.
But it says the mean. It doesn't say the variable.
The variable here, like in the first and column A and B.
Yeah, but it asks for the mean. So that's what we did. That's what I did. I put the mean, and then the standard deviation, and then the sample size. Make sense?
No, I'm not sure.
Because the other table, when I was doing the thingy, I was doing the same. I was putting the information in the first option.
Because we don't really put that difference. Let's see. One. Data. Statistic. Nope. Yes, this one. So because when I was watching at the tutorial video, he just used the screen the Excel sheet that I was showing at first, and it was just use the information from there to answer the assignments that we have.
Mommy, I'm just gonna tell
Okay.
you something. I just want orange juice.
Let me change them. I don't understand, but I believe you.
Because right now the question is asking for the degrees of freedom. It's asking for the sample standard deviation. It's asking for the statistic, the test statistic, the p-value, and then is what is the decision based on the evidence. It doesn't really ask us for what I mean of a specific, because we're gonna compare both means. Because the independent, test is different from the when we do the dependent, that one has to compare to the other based on the other. So I think that if we put in the information that we get in the Excel sheet, we can get the answer right. What do you think?
So 37.996.
For the number 6 question, the degrees of freedom. And then for the standard deviation for Rexburg. So the Rexburg is variable 2. So for variable 2, the standard deviation should be 206.637.
Yeah.
Okay, hold on, let me write down. And then what is the statistic test? So I would say T is equal to minus 0.434. And then the p-value for number 9 is 0.666.
Wait, did you select the right?
I'm sorry, what?
Did you select the right, the left, or the middle?
For what? For the p-value?
For the output.
Oh, I just select the p-value given on the here.
We need to change the degrees of freedom. Did you put in the output?
No, I didn't put information in the Apple.
Why not?
Because it was just giving me the t-value from the Excel sheet.
So the p-value is the statistic test. Is that right?
Yeah.
0.667.
Oh, okay. Yeah, 7.
Is that right?
Yeah, I was gonna put 6, but yeah, you can round it to the 7, I guess. So since the
But he asked
p-value
again, what is the p-value?
0.667.
Yeah, but what about the test statistic? Number 8. What is the test statistic?
Minus 0.434.
Oh, so the test statistic is the t-value.
Yes.
Okay, now I understood.
Mhm.
That wasn't making sense for me. I was like, wait.
Mhm.
Okay. What is the correct decision based on this evidence? What is our... Okay, our A is 0.10.
1.
We have a greater.
So I say it's the hypothesis is that it's a perform a hypothesis that determine if the mean bill of the Idaho Falls is less than the mean bill at the Rexford office. So
Our p-value is greater than our level of significance, so we fail to reject, right?
hold on, let me see. So the mean for the variable 1 is 260.059, and the variable 288, so it's less. The p-value is 0.667. So the p-value is greater than the level of significance.
Yeah, so we fail.
We fail to reject. Yes.
Suppose instead you had used the alternative hypothesis. What is the correct decision based on this evidence? If it's not equal, we just change in the table, right?
Because you use an the alternative hypothesis is just different. So when it's different, okay, so we can change to that. Not equal.
Wait, we fail to reject.
Yes.
So the answer would be insufficient. So it will be the second or the fourth.
Okay, let me see. So we have insufficient.
I think I would say the fourth one. Because we reject.
Okay.
No, I think it's the second one actually. We have insufficient evidence that the mean dentist bills between the two cities are different. Because if you reject, it means they are the same.
So we have insufficient evidence to say that there is a difference between the rates.
So I would say the second one.
Mm-hmm.
Well,
and
What do you think?
different. Yeah, the second one. I agree.
Okay.
Sorry, I have to read them all, and I'm slow.
Okay, take your time.
Okay.
Okay, the freshman dinner.
Okay, now another one. Okay. Let me close the dentist so I don't get confused. So now it's then. So I'm gonna do the same, just copy and paste the values.
Yeah, I'm getting the mean and the standard deviation. First.
Okay.
What did you get for the means and the standard deviations?
So for the first one, the variable one, let me see. So the variable one is Utah, and the variable 2 is Colorado. So for the variable 1, I got the mean 16.6067.
Okay.
And the variable 2, the mean, I got 15.200.
I got a different one. Let me do again. Okay, 15.2.
Uh-huh.
And standard deviation?
The standard deviation for the variable 1, 3.420.
Okay.
For variable 2, 4.517.
Okay, and sample size is 12 and 10, right?
Yes.
Okay. Let's see the question. This data represents the number of times freshman students from Utah and Colorado cook their own dinner in a month. Let represent the mean number of times a month that student in Colorado cooks dinner. Okay. You suspect that freshmen from Utah cook dinner for themselves a different number of times than freshmen from Colorado. Perform a hypothesis test to determine if your suspicion is correct. No hypothesis is equal. Okay, so if the null hypothesis,
So it's just different. It's just that it's different. When
so
I
now we have to change in the table, have to put equal to, right? In the type of test,
not equal to.
not equal to. What is the appropriate alternative hypothesis? I think the second one, right?
Yeah, because it just wants to know if it's different.
Yeah. What is the test statistic? It is.
I got 0.847.
845. I have 0.845.
I'm sorry, 845. You're right.
Okay.
I don't know what I was. Can read my own numbers.
What is the p-value?
I got 0.410.
0.411, because we will.
You're right.
Okay.
I always forget to round to the next. Okay. Oh, okay. Hold on.
What decision do you make? So our p-value is greater again, right?
Yeah.
So we fail to reject.
Yes, that is correct.
Determine a 95% confidence interval for one first mean minus second one. An estimate for the difference between, put your answer below. Can we use the information from the table, or we need to make the difference?
Also, the chart gives you what confidence level you wanna use, and then it gives you the confidence
So
interval too.
the lower one is negative 2.214, right?
Yes.
Oh, first he wants the margin of error.
Okay.
We need to
So.
calculate the margin of error. It is, where's my calculator?
There's a formula, right?
Never put the formula. So it's but wait, which sample size are we gonna use?
To get the margin of error of the two samples, we need to use both. So we use the standard. The formula is t. So we have the t value that is 0.845.
But he wants to know the margin of error, right?
Yes.
For
So
that, we use 1.96 multiplying standard deviation divided per square root of sample size, isn't it?
Look, let me show you that my screen.
Okay.
So you see the confidence interval for independent samples. So it says the margin error is this formula. Do you see it?
Oh, okay.
So we use the sample 1, sample 2.
Let me take. Can I copy that pretty quickly? Because from the textbook, they didn't have this. So it's t multiplying standard deviation 2 plus, no, standard deviation 1 plus standard deviation 2 and 1 and 2. Okay. Thanks, Julia.
Oh, okay.
Okay, let me do it.
So also let's go look the numbers to see what. Deviation first one.
Okay, I got 0.725.
So I'm still working on my formula.
Take your time.
so sorry. Sorry.
Take your time.
I need to do the square root of 3.015 on my computer. So let me just hold on. Do that. The truth of so I get 1.736. Is that what you got?
No, I get 0.725. I can do it again just to make sure. Let's see. So standard deviation, it's 3.420 dividing.
No, but first you do the square root. No square root, exponent to the second.
I think I need to do the equation inside first, right?
Yeah, like so that. So the standard deviation is supposed to be to the exponent to the like if it's 3.420 times 3.420 because that's the exponent to the second.
Oh, so it's multiplying, it's not adding.
No, yes, it's adding after. So it's S1 to the square to the second exponent or to the square.
Can I see the formula again?
Yes, I can show you. Yeah, the numbers are really small, so that's why it doesn't really show. Let me share. So let me put it a little bit bigger. So you see, it's S1, but it's the second. The square.
I didn't do it squared.
Yeah, I didn't do the first one too. I was like, oh, why?
Okay, let me do it again. So it's 2.42 squared dividing per 12 plus 4.517 squared dividing per 10. Square root of this multiplying per 0.845, right?
I'm sorry, what?
1.467.
Yeah, 4.567 to the square root 2 divided by 10.
Mommy,
Dividing by 10? Why by 10?
Because it's the second
no.
the number of examples are different.
No, my final answer is 1.467.
1.7. Okay, hold on. 1.9747.
How much did you get?
I got hold on. 1.736.
So let's do again together.
So
Three
square
point-
root of, or the square root, exponent.
so 3.42
I got
squared, right?
11.
Dividing per 12.
0.6964 divided by
No,
12.
no. First we do 3.42 squared dividing per 12.
Yes.
It's equal 0.9749.
0.9747.
Yeah.
Okay, yeah, I got that.
Plus 4.517 squared dividing per 10.
Yes.
Okay, 3.015.
Oh. So you already do the adding?
Yes. I put in parentheses 4.517 squared dividing per 10. And then I got 3.015.
I got 2.04. And then when you add the 0.947, that's when I got 3.015.
Yeah, that's what I got too. I add already.
Okay, so you got 3.015.
Yeah.
And
Then
you
we
do the
do square root of it and we get 1.736, right?
Yes, 1.736.
Now we multiply per 0.845, right?
Oh, that's the one. Oh, that's the one that I forgot to multiply. So sorry, Camila.
Okay.
So you multiply 1.736 times the
0.845.
45. Yeah.
And then we get 1.467.
Times 0.845. So 1.467.
Yep.
Oh, sorry. Yes, I was missing the multiplication.
And then now for the next two ones, just copy the lower bound and the upper bound.
Okay, let me.
And we got this.
So the 1. So the lowest is minus 2.214, right?
Hey, we got many wrong.
Oh no.
We got only 14 right.
Oh. No.
Oh, dude, I don't like this class at all.
Yeah, I thought that we were gonna do pretty good. You think because of the decimal places or anything?
Yeah, I submitted already. And retake it.
Oh no.
I don't understand. Seriously. We did exactly as it is in the table. What is it wrong?
Yeah. Yeah, I mean we follow the all the tests, I know everything.
Do you wanna try these other ones like together or do you wanna try later on your own?
Yeah, maybe later because I need to put my kids down to bed and they're starting to like come and bug me.
Okay, sounds good.
Hmm. That
Thanks
sucks.
for your patience.
Oh no, thank you too. Oh, no, I'm
Just
just gonna
here.
try once I put them to bed so I can concentrate and go through
Did you
this
get
again.
how many wrong did you get?
Let me see. 1, 2. What? 4.
So you got 14 as well, or 15?
I got 15 right.
Ah, which one did you get different?
Okay, let me go to the beginning to see which are.
So I got 6 wrong. I got 9 wrong.
Oh, the 6, I got it right.
What did you put in the 6?
37.996.
Oh, I put 36.997.
Oh. Yeah, that one. 9. You know the one that. So.
Yeah, I got wrong 9.
9 and then 13.
I got 13 wrong too.
Mhm.
I
And
think
16.
for the
16
test statistic, we should have put the t-score in the output, and then our area would be our test statistic, don't you think?
Yeah, probably.
Because we put just the t-score, we didn't put the test statistic.
Yeah, that's true. So like when I highlight, there is it says feedback, view
Does
feedback,
it give
and the
the
ones that we
answer?
got wrong, it says the answer in SPPS is slightly higher than in Excel. So the answer given is the average between the two results. Your result should be closer to the answer shown.
What?
So it says that we should have done it. I don't even have the SPPS software.
Neither, I don't as well.
So like they should have told us that we have to, do it in bots and then like do the average or to download that software. I don't know.
But wait, how do you do that? Because he's asking for the margin of error, and we followed the freaking formula. If it's not the way that we do, how are we supposed to do it? Seriously.
Yeah. Yeah, I don't know.
This feedback and nothing is the same thing.
Yeah. The only thing that I'm thinking about the 95% that we could have done different instead of put the T to put the how we used to convert the 95 into 1.96.
Because so like if we don't buy this app, this thingy, our answers will always be wrong. Because we just follow the instructions in Excel.
Yeah,
So we have to buy it.
I guess we should like ask the like in the discussion board, not in the discussion board, in the questions to the teacher to see what we get or how we can get that, or like how the Microsoft Office they offer us to the student for like free, so to see if they have a link that we can get the SPS.
I don't think it's free because I started taking this class last semester, but then I dropped, and then we had to pay for this, and I think it was like $30, something like that.
Oh wow.
30 or 20, I don't remember very well, but it wasn't free. We had to pay.
Wow. I guess then
But like for tonight, then we won't get the answers because
with the answer from the SPS.
is that another way to do than having the app thingy?
I don't know. I don't know if like manually, like just follow the formulas, for everything.
which will take forever.
Yeah. Yeah, pretty much.
Okay, Julia.
Okay.
Thank you so much.
Stop the recording.